Hey guys, so we are going to be doing a comparison between red wine and water. So we'll be conducting an experiment where we try to calculate the buoyancy of red wine and of water. So we'll be conducting an experiment where we take a Coke can and cover it with a body of water and of red wine. And we're going to be seeing if the can is going to either float or sink. But before we start this experiment, comment in the section below if you think that the can will float in the red wine or water. So without further ado, let's start this experiment. In this experiment we'll be needing a Coke can, a container to hold all the fluids, and some lovely red wine and water. The container is filled with water and we're going to place the Coke can inside the water to see if it will float. At the moment you can see that the can is not floating. But in the end you will see that the can actually starts to float up. We'll later discuss why this happens. Now let's see if there's any differences with red wine. So we place the can in the red wine. As you can see, the can does not float up. Now let's discuss why this is happening. So according to Archimedes' principle, my force of buoyancy is equal to the weight of my object, right? So let's calculate for water. So my FB, which is my buoyancy force, is equal to rho times G times V, which is my volume of my liquid displaced. Okay, so we know that for water, my density is 1000 times gravity, which is 9.81, times my volume displaced is my area times my height displaced. So my area, since it was a container, we use pi d squared over 4. And my diameter is 0,207 squared over 4 times my displacement, which we found out to be 5.8 millimeters. So this gives us an answer of 1,915 newtons. Let's calculate the force for wine. So again we have my force of buoyancy is equal to rho g v. My density of wine was 985.7 times by gravity and then times by my volume. So it is the same container, so the diameter is the same and the liquid, or the height, sorry, displaced was exactly the same. So this gives us a total of 1,887 newtons. Already you can see that the force, the buoyancy force of the water is much larger than the buoyancy force of the wine. And if you remember in the video, the can did not float in the wine, but it did float in the water. So let's just calculate the weight of this object. So my weight is equal to mass times gravity. We have a 200 milliliter can, which means it's 0,2 kilograms times by 9.81, and this gives us a force of 1,962 newtons. As you can see, my force of buoyancy of my water is much closer to the weight of my object than that of my wine. That is why in the video it was evident that the can started floating when it was placed in the water. And the reason why it did not float when it was placed in the wine was because my force of buoyancy in the wine was not great enough to overcome my weight of my object.